Welcome to another video. In this video I'm going to give an overview or preview I should say of the law of sines and the law of cosines. Now, the law of sines and the law of cosines are used to solve triangles. That is, you'll be given a side and two angles, or two angles and a side. In other words, you're given parts of a triangle and you're asked to find the missing parts. It could be the lengths of the remaining sides or the measures of the angles. Now, you start off basically by solving right triangles. Now, the law of cosines and the law of sines are used to solve oblique triangles. That is, triangles that do not have a right angle. So before I get started with that, let me look at an example of solving a right triangle. So let's suppose I have this triangle here. Okay, so let's suppose it's a right triangle. It doesn't look like it, but let's assume it is. And let's make this side 4 units, whatever it is, inches, feet, and let's say the right angle is right here. So let's label this angle over here A, this C, and let's say this B. And you're asked to find the missing parts. So basically I know that the legs of the triangle are 4 units and 3 units. That's given. And of course angle C is understood here to be a right angle. So this is 90 degrees. So I know that angle A and B are complementary. So once I find one of those, I know the other one because they're complementary. So in this type of problem, you can just use your definitions of the trig function. So here, for example, I can say the tangent of angle A, using the definition of tangent, is equal to the opposite side over the adjacent side. Okay, and then I could solve that for A. So angle A is going to equal to tangent inverse of 4/3. Tangent inverse of 4/3. So here I'm going to go to the calculator, and I'm going to hit second here. Make sure the calculator is in degrees, so you go to mode, and that's what happens with these virtual calculators. Sometimes you have to reset them. So let me reset mine. Okay, so let me go to mode. And this one's in radians. So let's suppose they want the answer in degrees. I go over to degrees, hit enter. Okay, so now I go out of this menu. Make sure you always know what your calculator is set. You might think you're computing degrees and you're computing radians. Okay, so in this case then angle A would be tangent inverse. So I get the inverse and then enter 4 divide by 3. And I get 53.1. So let's say that angle A is 53 degrees. Well, because angle A and angle B are complementary, I know that angle B then is 90 minus 53, or 37 degrees. There you have it. Okay, so what are we missing now? We have, obviously angle C is 90 degrees, so we know that. So the only thing we're missing is the hypotenuse, or the side opposite angle C. Now here again, I could use the sine or cosine to find that, but in a right triangle, the Pythagorean theorem applies. So that means that this side here, which is C, we'll label that C, little c. That means then the hypotenuse theorem, or the Pythagorean theorem, tells us that c squared has to be 4 squared, which is 16. In other words, the sum of the squares of the legs. So c squared is equal to 16 plus 9, that's 25. So if I take the square root of that, I get the side then is 5 units. Okay, so that's basically how you solve a right triangle. You can apply the Pythagorean theorem. You can apply the basic trig functions, either the sine, the cosine, or here in this case I use the tangent to find angle A. This, of course, is not going to work. This is only going to work if this angle right here is 90 degrees. If this angle here is, say, 80 degrees, then you can't say that the tangent of A is going to be this over this. That only applies if it's a right triangle. Okay, so if you're dealing with oblique triangles, this is not going to work. So that's what we have to use, the law of sines or the law of cosines. So let me clear this. Okay, first before I do this, let's look at the formulas we have here. Okay, so here's the statements for the law of sines and the law of cosines. So this says for a triangle with angles A, B, C, so the capital A, B, and C represent the angles of the triangle, and opposite sides A, B, C. So A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Then the law of sines tells me that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. So given any three of these, I could use this formula right here, or if I'm given any three of these, then I would use this formula here, and so forth. So it's depending on what you're given. This is the law of sines. Keep in mind that I could also write this as A over sine of A, little b over sine of B, and little c over sine of C. Okay, that's just algebra. I could also do it like that. Okay, now the law of cosines tells me, again, if A, B, and C are the sides of the triangle, and capital A, B, and C are the angles opposite those sides respectively, then the law of sines has three formulas, and here you have it. A squared is equal to B squared plus C squared minus 2BC cosine A, and so on. Okay, so those are your formulas. And now in the videos that I have, I'll be first looking at some problems from the law of sines, and then in following videos I'll be looking at the problems from using the law of cosines, and of course I'll also have some application problems. But these are the formulas. Okay. Now let me look with you at this right here. So if you're solving an oblique triangle, that is a triangle that does not have a right angle. I also want you to keep in mind a few things. Obviously, you should know that in any triangle, if you add up the angles of the triangle, A, B, and C, if you add those up, that's always going to add up to 180 degrees. Also keep in mind that the largest angle of the triangle is always opposite the longest side. And the smallest angle, obviously, is opposite the smaller side. That's something to keep in mind. The other thing I want you to keep in mind also when you're working these types of problems, that If you take, obviously when you're solving triangles, your answer is always going to be a value between 0 and 180, right? Because the sum of the angles is 180, so you can't have an angle larger than 180. So some of the angles are going to be acute, angles between 0 and 90. Some of the angles are going to be obtuse, somewhere between 90 and 180. And then the sum, again, as I said, of the three angles is 180. So here are the scenarios that you're going to have. Okay, so this will be a preview, and like I said, I'll be using these scenarios in the problems that I'll be solving. But here's a case one that you can have. You're given one side and two angles. Okay, so here, side angle, angle, or angle, side angle. Okay, so you're given two of the angles. So obviously if you're given two of the angles, it's pretty easy to find the third angle because you know that the sum is 180. The sum of all three is 180. So you add up the two angles and subtract from 180 and you get the measure of the third angle. So over here in the suggested procedure, step 1 states find the remaining angle using the angle sum formula. A plus B plus C is equal to 180, which is what I just said. And then for step 2, then obviously we need the side. Find the remaining sides, in this case two sides, find the remaining sides using the law of sines. So that'll be those formulas that I just referred to a while ago. Okay, now case 1 is pretty straightforward. No issues, just a matter of using your formulas and the calculator. Case 2 is the one you have to be careful about. So in this case, you're given two sides and one angle. Notice in parentheses it says the angle is not included between the two sides. So in other words, what you're given is you're given two sides and the angle opposite. Okay, the angle opposite one of the sides. Okay, so on the right it tells you be aware of the ambiguous case. Okay, so the situation here is in this scenario here, there could be no triangle, okay, one triangle, or two triangles. So in other words, picture this, you have two sides, and then say you're trying to construct the triangle, and then the third side say it's too small. You can't form the triangle. So that'll be an example where you have no triangle. And then there's a scenario where the side is long enough where you can move it to one end or the other end and form two triangles. Okay, so here's the situation. Step 1, you're given, again, two sides and the angle opposite this, one of the sides. So step 1 says find the angle using the law of sines. Okay, so you're going to set up the formula. You're going to set up the formula for the law of sines using the information given, and you're going to find the value of one angle, a second angle. And then step 2, now you know two angles. Find the remaining angle using the angle sum formula. Okay, so once you find that second angle, then you just add them up, subtract from 180, and you have it. And then step 3, find the remaining side using the law of sines. Okay. Now, down here it says if two triangles exist, repeat step 2 and 3. Okay, so how are you going to know if you have two triangles? Well, here's what happens in this particular case. Let me remind you that if you have two angles that are supplements of each other, if two angles are supplements of each other, in other words, they add up to 180. So take, for example, 45 degrees and 135. 45 degrees and 135. If you take the sine of 45 degrees using your triangle, or I'm sorry, using your calculator, and you take the sine of 135, you're going to get the same answer. You're going to get the same answer. So that's going to be one of the clues that to tell you what you're going to do. Okay, so down at the bottom, here's a suggestion. In the ambiguous case, if a solution exists, find the supplement of the angle. Okay, so let's say on this one over here, you found the first angle. using the law of sines. And let's say as an example, let's say you got 45 degrees. Then you find the supplement of that angle, which is 135. Okay, so now if the triangle has two solutions, then that angle, whichever you found, whether it was angle A or angle B, in one solution, the angle will have a value of 45 degrees, and in the other solution, the second solution, is going to be 135. That's why here at the bottom, it states, in the ambiguous case, if a solution exists, find the supplement of the angle found. Okay, and here's what you do. If the supplement angle plus the given angle, okay, the given angle is the one that's given in the problem, you add those up, and if that's less than 180, then there are two triangles possible. Okay. Now, if the supplement angle plus the given angle is greater than or equal to 180, that means, okay, you can't form a triangle because it's over 180, then only one triangle is possible. So in this scenario, like I said, if you got 45 degrees, then 45 would be the solution, and there would only be one solution. Otherwise, 135 would also be a solution. Okay. And this will be clear to you if it isn't right now when I actually work the examples in the next video. Right now I'm just kind of setting the foundation as to what I'm going to be doing, and I'll go over this again with you, but this is just a little preview of what's coming. Okay, now in case 3, let's suppose you're given two sides and the included angle. Two sides and the included angle are known. So this one you would call it side, angle, side. Now in this case, the law of sines is not going to work. Okay, but this is where you're going to be using the law of cosines. Okay, so in step 1, find the third side using the law of cosines. Okay, so you'll use the formulas that I went over a while ago. Find the third side. Okay, so now you're going to have 3 sides because 2 sides are given. Now in step 2, it says find the smaller of the 2 remaining angles. Now once you find that third side, now you have enough information to use the law of sines. So set up the appropriate equation and find the smaller of the 2 remaining angles using the law of sines. Now once you know the 2 angles, you can get the third angle by just adding those up and subtracting from 180. Okay. Case 4. In this scenario, you're given all 3 sides. So SSS, side, side, side. So you don't know any of the angles, you know all the 3 sides. So you're going to use the appropriate formula. And like I said, I'll work some examples like this. And here are the steps that you're going to go through. Find the largest angle using the law of cosines. Find the largest angle using the law of cosines. And then step 2, find either remaining angle using the law of sines. Now I want to point out to you that you don't have to use the law of sines here if you don't want to. You can strictly use the law of cosines and find all 3 angles, or actually find 2 of the angles, and then once you have the 2, add them and subtract it from 180 and you have it. But it's easier to work with the formula for the law of sines than it is for cosines. That's why in this case they tell you find the largest angle using the law of cosines, and this again is going to avoid the ambiguity that you can have with the law of sines. Whether the supplement is going to be a solution or not, you don't have to worry if you find the largest angle first, because now if you find the largest angle first, you know that the other 2 angles have to be acute, right? Because you can only have one obtuse angle. So if you know the largest, whether it's obtuse or not, the other 2 have to be acute. Okay, so find the largest angle using the law of cosines, and then find either remaining angle using the law of sines, and then find the remaining angle using the angle sum formula. So in other words, once you know the 2 angles, it's easy to get the third one because you know they have to add up to 180. Okay, so this is the foundation that I'm setting here for the maybe 2, 3, or 4 videos that are coming up on law of sines and law of cosines, and I'm going to deal with all the different scenarios and briefly go over some of these with you. But this is just a setting the foundation for what's to come. So again, if you think some of this will help you, please subscribe. And again, I urge you to post anything concerning tutorials, any videos or example problems, or the types of problems you want videos on, and I'll consider those for anybody that subscribes to my channel. I appreciate it, and I'll see you in the next video.